Hi guys, and welcome back to Aisha's Academy. So I know it's been quite high demand at the moment, so I'm really trying to go through as much as possible. But today I'll be going through the higher algebra Edexcel maths questions. I've already put the Edexcel ones up, so this is for those that are sitting higher. So let's just get right into it. So this is how it would appear. Okay, so go straight into question one. So question one, it says m to the power of 3 times m to the 4. So remember, whenever you're multiplying your indices, you always add the powers together. So that would be m to the power of 3 plus the 4, which would be m to the power of 7. And then having a look at part B, it says 32Q9. So I'm going to write it out clearer, just in case some people might not be able to see it. So it says 32Q9 R4, and then 4Q3 R. So when it comes to simplifying, you're always collecting the like terms, right? So we're going to do it bit by bit. So first things first, we're going to divide the two numbers by each other. So we're going to do 32 divided by 4, which is 8. Then we are going to do the Q9, Q to the power of 9. I know they look really similar, but Q to the power of 9 divided by Q to the power of 3. So whenever you divide indices, you take away from the powers, which will leave you Q to the 6. And then with the R, it will be R to the power of 4 divided by R. And then you take away again from the powers. So remember, anything that's written on its own is the same as saying to the power of 1. So the same as saying R to the power of 4 minus 1, which is R to the power of 3. So that would be the final answer. Okay, so moving on to question 2. So it's showing this number line and it wants us to show the set of values of x for which minus 2 is less than x plus 3, which is less than or equal to 4. So where this could trick people is on the number line, you need to show the values of x. So we need to change this inequality. So we need to change it to show the values of x. And to do that, we're going to take away 3 on each aspect of the inequality. And by doing that, that would leave us with minus 5 is less than x. And now we've just got x on its own. We can work out the values of x, which is less than or equal to 1. So then now that we have that, we know the actual set of values of x. So then to draw it on the number line, we're going to put circle over minus 5 and a circle over 1. So remember, whenever you've got a less than or equal to or a greater than or equal to sign, it's coloured in. So then that's why it's coloured in over the 1. And then it's a sandwich. Oh, it's a sandwich inequality. So we would connect them together. And then question 3 is showing 6 graphs. So here are the graphs. So it wants us to write down the letter of the graph that could be that equation. So the first one is y is equal to x cubed. So a cubic graph usually presents as this. So just drawing it quickly here. So the one that's closest to that shape is F. So with the shapes of graphs and things like your cubic and quadratic graph, just be familiar with them and learn them. So then with part B, the next graph is y is equal to 1 over x. So in regards to a reciprocal graph like that, it would usually look like this. So with these kind of graphs, they present with asymptotes. So then the one that's closest to that is D. Okay, so moving on to question 4. So in this question, it's in terms of arithmetic sequences. So I'm just going to rewrite the numbers out when they're spread out, just so you can see it clearly. So it just wants us to work out the nth term. So in terms of doing that, you need to work out the differences between all the numbers. So that would be plus 3 each time. So because the difference is equally 3, 3, 3, we can happily say that that first term is going to be 3n. Then we would write out 3n, and we need to work out the first 3 terms. I always do the first 3. 3 is like a lucky number, I guess. So we work out the first 3 terms of when the sequence is 3n. So when n is 1, 3n would be 3. When it's 2, it would be 6. When it's 3, it would be 9. And then we're going to use the terms that we've been given, which was 1, 4, and 7. They were the first 3 terms. We're going to work out the difference between 3n and the terms that are in the sequence. So to get from 3 to 1 with minus 2, 6 to 4 minus 2, 9 to 7 minus 2. So they're all equally minus 2. So we can happily say that the whole sequence is 3n minus 2. Okay, so having a look at question 5a, it is slightly squished when downloading it. So I'm just going to redraw it out. Okay, so it wants us to basically complete the table of values. So we know that one. So by doing that, we're going to substitute each value of x into the equation they've given. So the first one is minus 2. So then the first term would be y is equal to 5 minus 2 cubed. So minus 2 cubed is minus 8. So that would be 5 minus minus 8. And remember, if you've got two negatives next to each other, it becomes a positive. So it'll be 5 plus 8, which is 13. Then for minus 1, it's been given to us. For 0, it's just going to be 0, which is going to leave us with 5. For 1, it's going to be 5 minus 1 cubed, which is going to be 5 minus 1, which is 4. And then for 2, it's going to be y is equal to 5 minus 2 cubed, which 5 minus 8 would be minus 3. And then it wants us to plot this onto the graph. So the graph is down here. So again, I'm just going to rewrite the table of values quickly so it's closer to the graph. So it's minus 3, 4, 5, 6, and 13. So yeah, just plot them on really. So then x minus 2, y is 13. So then that would be there. Then for minus 1, it's 6. 0 is 5. 4. And then we just connect it all together. Okay, and that's literally that. And then question 6, we've got a quadratic equation equal to 0, and it wants us to work out the solutions to 3 significant figures. So I have mentioned this before in my videos. Whenever you're solving a quadratic equation, if it wants it in significant figures or decimal places, you're using quadratic formula. If it doesn't mention it in regards to significant figures or decimal places, then you would just factorize, double bracket factorizing. So then quadratic formula is minus b plus or minus root b squared minus 4ac over 2a. So now we are going to write out our a, b, and c values. So in this question, a is 5, b is minus 4, c is minus 3. So now substituting them in. So notice how it's minus b. So if it's minus b, our b value is minus 4. So it will be minus minus 4. Two minuses make a positive. Hence why it's plus 4. And then that will be plus or minus, so b squared, so minus 4 squared minus 4 times 5 times minus 3 bracket, and then 2 times 5, which would be 10. So then literally you're going to put into your calculator 2 separate ones. So you're going to do it when it's 4 plus all of that. And then you're going to do it when it's 4 minus all of that. And that's why with quadratic formula, you always end up with 2 answers. And it usually is where one is positive and one is negative. Okay, so then put that all into your calculator and you should get, so you'd end up with, so for the positive aspect, you'd end up with 1.27, and then the negative one would be negative 0.471. Sorry, correction 2, because it would have rounded up. So the key thing here is that both of my answers are in 3 significant figures, which is what they want. So going on to question 7, it's given us this formula and it wants us to rearrange it to make phi the subject. So the first thing that we're going to do is we're going to multiply both sides by phi to get rid of the fraction. So by doing that, you'd end up with WV is equal to 15 bracket t minus 2v. So now we're going to expand the brackets. So that would be 15t minus 30v. The reason why I've expanded the brackets is now we're going to collect all the terms with v with them on one side and the ones with no v on the other side. So we're going to add 30v to both sides. And that's going to leave us with wv plus 30v is equal to 15t. So now that we have that, we are going to factorize. And then by factorizing, that would leave us with v bracket w plus 30, close bracket, is equal to 15t. And then literally now we're going to divide both sides by w plus 30, which is going to leave us with v is equal to 15t over w plus 30. And that's literally it. Okay, so moving on to question 8. So question 8 says a straight line L1 has an equation y equals 3x minus 4, and L2 is perpendicular to L1. So let's just draw an imaginary graph. This is not drawn to scale, by the way. This is just for the purpose of your understanding, before anyone comes and comments below. So like I said, this is really not drawn to scale. I'm just trying to help you visualize. So let's say if this is our L1. So if L2 is perpendicular, then I'll draw L2 in a different color. Remember, perpendicular forms a right angle. So that would be our L2. And it says that they both pass at the point 9, 5. So again, obviously, as we can see, this is really not drawn to scale. So this, we're going to call it 9, 5. No, I'm sorry, I can't deal with the mathematical errors in this situation. I really don't want you guys to be roasting me in the comments, so I'm gonna do this correctly. Okay, that looks somewhat better. Alright, so it crosses at 9, 5, and the whole point is we're meant to work out the equation of L2. So in a situation like this, remember it's the whole concept of your straight lines, which is y equals mx plus c. Remember m is our gradient. And for L1, we know that the gradient is 3. So then for L2, remember for perpendicular lines, the gradient is the negative reciprocal. And what that basically means in non-mathematical jargon is you make it into a fraction and you stick a negative sign in front of it. So for L1, if it's equal to 3, L2 would be a third, negative a third. Okay, so then now we know the gradient for L2. So far we've got y is equal to a third x plus c. So now to work out what our c is, our y-intercept, we're going to substitute the coordinates 9, 5, because the line L2 crosses through that coordinate into the equation to work out what c is. So that would be 9, correction, not 9. That would be 5 is equal to minus a third times 9 plus c. So then that would be 5 is equal to minus 3 plus c. Rearrange that. So 5 plus 3 is equal to c. So c is equal to 8. So then the final answer would be y is equal to minus a third x plus 8. And that is it. Okay, so moving on to question 9. Question 9, it wants us to solve an algebraic fraction. So when it comes to scenarios like this, there's multiple ways that you can do it, to be honest with you. But the main way I like to do is make sure that the denominators are all the same. So by doing that, the whole first equation, I'm going to multiply it by 3, the second one by 4, and the last one by 2. And by doing that, because all the denominators will be 12, that's actually going to cancel it out. So I'll show you what I mean by that. So it'll be 3 times 3x minus 2, 12 minus 4 times 2x plus 5 over 12 equals 2 times 1 minus x over 12. Notice how they're all 12? Cancel it all out. But I wanted to just show you that first rather than just jump the gun. Okay, so now that we've done that, this is what we're left with. So now expand the brackets. So that's going to be 9x minus 6 minus 8x minus 20 is equal to 2 minus 2x. So then simplify, 9x minus 8x is going to be x, minus 6 minus 20 is equal to minus 26. That is equal to 2 minus 2x. Collect all the x's together, collect all the numbers together. So I'm going to add 2x to both sides, and then add 26 to both sides. And that's going to leave me with 3x is equal to 28. So then x is equal to 28 over 3. Okay, so moving on. I'll try it. Okay, so moving on to question 10, it wants us to expand this triple bracket. So whenever it comes to expanding 3 brackets, I always like to expand 2 brackets first, then multiply that massive bracket to the last bracket. So let's multiply these two by each other. So x minus 2 times 2x plus 3. So again, moon face or smiley face, whatever you've learned, or just drawing the lines out. So x times 2x is 2x squared. X times 3 is plus 3x. Minus 2 times 2x is minus 4x. Minus 2 times 3 is minus 6. So then that's going to simplify into 2x squared minus x minus 6. So then now I'm going to multiply that to the last bracket here, x plus 1. So again, draw the lines out. So I'll make 2x cubed, and then 2x squared, and then minus x squared, minus x, minus 6x, minus 6. Okay, so then that's going to simplify into 2x cubed. So the x squareds will collect together. So plus 2x minus x squared. Sorry, plus 2x squared minus x squared would leave us with plus x squared. And then minus x minus 6x would be minus 7x. And then you'd just be left with the minus 6. So that would be your final answer. Okay, and then moving on to question 11a, it's to show that the equation x cubed plus x is equal to 7, and we have to rearrange it into the format x is equal to square root, sorry, not square root, it's really badly shown. Again, I'm going to rewrite this so it's clear. Cube root 7 minus x. So the best way to do that is rearrange the cube. So the x cubed. So that would be x cubed plus x equals 7. I'm just rewriting it. So take away x from both sides. That'll leave you with x cubed equals 7 minus x. And then just cube root it. That will leave you with what they want to show you. So that's that bit done. Then it wants us to be doing iterations. So starting with x0 is 2. And we have to work out, it says use the iteration formula 3 times. So we're going to do it for x1, x2, and x3. Okay, so with x1 is equal to the cube root of 7 minus 2, because that's what x0 is. So that'll be the cube root of 5, which into our calculator would give us an answer of, so that would give you 1.709. Something along those lines. And then for x2, that is going to be the cube root of 7 take away what we've just worked out. So that would leave us with an answer of 1.74241888 and so on. Okay, and then x to the 3, or x3, so that would be 3 root 7 minus, and take away that answer. And that would leave us, if you put it all into your calculator, that would leave you with an answer of 1.738849, and so on. So I'm just going to make the handwriting slightly neater. And that's the 5, by the way, for anyone else. Okay, so yeah, to find an estimate for a solution. So now that we have worked that out, so one thing to note with this question is that the fact that it hasn't mentioned for you to leave your answer in specific decimal places or significant figures. If it does, then do so. But in that case, then we're just going to leave it like this. Okay, and then now next question 12 is on to composite functions. So in this case, it wants to show that g f of x is equal to 2x bracket x plus 2. So in regards to that, how I think of it is because you've got the f inside, so think of the g as like the mother of a baby and the f is the baby. So because f is within the womb, we're going to put the function f into function g. So then our function g of x is essentially, I can't even speak, let me rewrite that. Our function g f of x is essentially the function g, but with f of x instead. So like that. So now that we've done that, we're actually going to put the actual function of f of x, which was 2 bracket x plus 1 squared minus 1. Too many brackets, so we need to expand. We're going to expand the inside ones first. So that will be x squared plus 2x plus 1 minus 1. Simplify again further inside that bracket. So x squared won't change, neither will 2x, but plus 1 and minus 1 will cancel out. So then now we've got this, which is close to what we want. We want 2x on the outside. So literally we can see that the common factor inside the brackets is x. So we're going to bring x on the outside and therefore divide everything inside the brackets by x. So x squared divided by x is x. 2x divided by x is 2. And that is how we show that. Okay. So then on to question 13. It's given us a speed time graph and it wants us to work out an estimate for the distance for the train traveled in the first 20 seconds. And it wants us to use 4 strips of equal width. So with this question, the area underneath speed time graph is equal to distance. So we basically need to work out the area underneath. Now, because it wants us to use 4 equal widths and it wants it in the first 20 seconds, if we divide 20 by 4, we get 5. So we're going to work out the area for every 5 seconds. So that'll be 1, 2, 3. Okay, so the first shape, unlike the other 3, is a triangle. So for shape 1, we need to work out the area of a triangle. And to remind you, an area of a right angled triangle is half base times height. So in this scenario, for the first shape, it's going to be half times the base, which is 5, times the height, which we could say is about 2.5. Oh, sorry, not 2.5. Let me draw properly to scale. Yeah, at 2, not 2.5. So then times 2. And then for the other shapes, they are trapezium. So the area of a trapezium is half a plus b times the height. So a plus b, so if I quickly draw a trapezium, the a plus b are the 2 parallel lines, and then the height is just there. So in this scenario, these are going to be our a's and b's, and so on. So then it's going to be a half, right here, a half bracket. So the first a is going to be 2, because we know that length is 2, because we just used it for the triangle. And then the b is going to be 5. And then our height is 5 as well, because that's our height. So then that's that. Then for the second trapezium, it's going to be half. So our A is like our B from the last one. So that's going to be half 5 plus goes up to 10. And then again, the height is still 5. And then the last one is half 10 plus, looks like it's going to around 18. So I'll put 18, 5. Now, literally, I'm just going to work out everything. So half times 5 times 2 is 10. No, it's not. It's 5 plus, so 5 plus 2 is 7 times 5 times a half, which is 17.5. 5 plus 10, 15 times 5 divided by 2, which is 37.5. Plus, and then 10 plus 18 is 28 times 5 times a half, which is 70. Add them all together is going to give us an answer of 130 meters. And then having a look at question 14. So question 14, if I zoom in, it's got a lot going on. But again, I'm just going to write it out so it's nice and clearer. Okay, so it wants us to show that working that out is going to simplify to AX, A being a whole number. So that's what we should end up with. So the first thing that we're going to do is there's a lot going on. So we're going to literally factorize everything. So if I had to factorize 7x minus 14, that would leave me with, so the common factor is 7x, and then that would be, oh, not plus 14, it's a minus 2. Okay, and then if I had to factorize x squared plus 4x minus 12, I would end up with x plus 6, x minus 2. And then divide that by, so x minus 6 doesn't need any further factorizing. But now I've got x cubed minus 3x, 36x. So they both have x as a common factor. So I bring that out. Then now I've got x cubed minus 36, and I definitely know that can factorize further into x plus 6, x minus 6. So then that's that one. So I'm going to rub out that and put what we've just worked out. Okay, so now that we've worked that out, remember when it comes to dividing fractions, we flip them and that they end up being multiplied. So this is going to change to multiply, so x plus 6, x minus 6, and then x minus 6. I don't even need the brackets. Okay. All right, so what we can do is we can see that the numerator and the denominator both have x minus 6. Cancel out. And the numerator and the denominators both have x plus 6. Cancel out. The numerators and the denominators both have x minus 2. Cancel out. And what are we left with? 7 times x, which is 7x. And that's in the format they wanted. Okay, so moving on to question 15, it says the graph y equals f of x is shown on the grid. So let's go to the graph. Okay, so this is what's shown, and it wants us to draw the graph with the equation y is equal to f of x plus 1 minus 3. So as we can see, the x has changed. The x has been translated. And when you've got a sign in the x, so if it's plus 1 in the brackets, you're actually going to do minus 1. So what actually happens to x in the brackets is always opposite to what you do. So if it says x plus 1 in the brackets, we're actually going to take away 1 from all the x values. So I'll draw it in a different color so it doesn't clash. But obviously in your exam, I know you wouldn't. So everything would basically move back. Okay, so that's that. And then also you've got the minus 3 on the outside, which means all your y values are going to go down by 3 as well. So what actually happens to y in the equation is genuinely what is going to happen to y. It's only x where the opposite happens. So then you're going to move down 3 spaces. I'll put the thing in. So move down, and that's what we would do. I'll rub this one out so no one's confused. So that's where the final graph would be. Again, I know in your exam it would be in pencil, but just to show you the difference. Okay, so moving on to question 16. So question 16, it wants us to solve the simultaneous equation. This is the last question, by the way. So yeah, This is to do with quadratic simultaneous equations. So the first thing with quadratic simultaneous equations is you always get given like a quadratic formula and then a linear equation. So you want to substitute your linear equation into the quadratic one. So in this scenario, our linear one is x plus 2y is equal to 1. So the easiest thing really is to make it x is equal to. So x would be equal to 1 minus 2y. So now we know what x is, we're going to substitute that into the equation above. So then that's going to be 2 bracket 1 minus 2y squared minus y squared equals 17. Now we need to expand that. So 1 minus 2y squared is the same as saying 1 minus 2y times 1 minus 2y. Then we're going to expand. So 1 times 1 is 1. 1 times minus 2 is minus 2y. 1 minus 2y times 1 is minus 2y again. And then minus 2y times minus 2y is positive 4y squared. So remember, that was all multiplied by 2. So we're going to multiply that all by 2. So that'll be 2 minus 4y plus 8y squared. Collect the like terms. So then that's going to be 2 minus 8y plus 8y squared. And then we have our minus y squared from the top. So minus y squared equals to 17. That's going to simplify into, I'll remove the equal sign here so it doesn't confuse anyone. So that's going to simplify into 2 minus 8y. So you've got plus 8y squared minus y squared, which will be plus 7y squared, and that's equal to 17. Then I'm just going to rearrange it so it looks nicer. And then it was plus 2y, but we're going to also take away 17 from both sides at the same time. So by doing that, 2 minus 17 would give us an answer of minus 15. And that's all equal to 0. So now that we've got this equal to 0, we are going to need to factorize. So with 7y squared, one of your brackets is going to have 7y, one of your brackets is going to have y. And because it's making up 15 at the end, think of different pairs that make 15. So that's 3 times 5 and literally 15 times 1. So luckily, there's not that much variety. So I think the most likely pair, to be honest, actually, I think it's going to be the 15 and the 1. So if we put the 15 here and 1 here and make it positive, no, negative, plus. Yes, because if that was to expand, that would be 15y minus 15y, and that would be plus 7y. And minus 15y plus 7y does give negative 8y. So that's that. Okay, so now we have that, we're going to work out two values of y. So the first one, so 7y minus 15 equals 0. 7y would be equal to 15. Y is equal to 15 over 7. Then the other one is quite nice and simple, where y is just equal to minus 1. So our two values of y are, I'll just write them at the bottom here. So y is equal to 15 over 7 and minus 1. And then we're going to substitute our two values of y into the linear equation, preferably because you want to make your life easier. So I'm going to rewrite the linear equation down here, which was x plus 2y is equal to 1. So the first one that we can substitute in is when y is equal to 15 over 7. And so that would be x is equal to 2, not x is equal to, x plus 2 times 15 over 7 is equal to 1. So x plus 30 over 7 is equal to 1. So x is equal to 1 minus 30 over 7, which is the same as saying 7 over 7 minus 30 over 7, which is minus 23 over 7. So that's for x. And then the other value of x, we're going to substitute when y is equal to minus 1. And so x plus 2 times minus 1 is equal to 1. So then x minus 2 is equal to 1. So then x is equal to 3. And that is basically the end of the algebra Edexcel Higher 2021 assessment material. I hope that was useful. Thanks for watching.